Hi everyone. I wanted to share with you today the process I had to go through to build libcamera stack from the sources in order for me to get the GStreamer plugin so that I can use that plugin under OpenCV in my application. The application that I'm referring to is this CV Timex. I demonstrated it in the past, also in the more recent video. It just does a 10-minute time exposure from the camera image and various computer vision tasks. In order to build it on the Raspberry Pi 5 under Raspbian OS version 12, which is bookworm, I had to build the libcamera from sources. When I was trying to get OpenCV to use the V4L2 camera APIs, that wasn't working for me, so I instead went with the GStreamer backend that exists in OpenCV. But in order to get that OpenCV's GStreamer backend to work with libcamera, I had to build libcamera from source in order to get the libcamera plugin. Then I was able to add that to the path, and the whole stack became workable for me. So I wanted to show you the process of building and take you through that in this video. Here's some system information. I'm running on the Linux kernel 6.662, and it's built for the 64-bit Arch64 architecture. Running Debian Raspbian, which is a version of Debian 12. Bookworm is the code name. I have a 128 gig hard micro SD card in here, and this Raspberry Pi 5 has 4 gig of RAM. Not much of swap space is being used, but it does have some swap enabled. Currently, I have OpenCV version 4.10, which I built from sources after building the libcamera stack. And here is the information about the libcamera version. Although this will not change, the only benefit of building it from source is that I will be able to get the libcamera source pipeline plugin. But the versions of libcamera is v03.2, and this is the commit hash. Actually, this part of it, that's the latest. And the camera apps, RPiCam apps, are also built will have to be built from source. Anytime I build libcamera, I also build RPiCam apps. The version of the camera apps is version 1.53, and I will show that in the video as well. That way they match each other. In order to build RPiCam apps, there is another library called libepoxy that also has to be rebuilt from sources in order to enable it for OpenCV. So 3 different builds. I'll try to expedite it. I'll first show you the dependencies and the packages that I had to install. Here are the packages with apt that had to be installed as dependencies for the build. There's a ton of them. I will leave it up for a sec, but I would also post this list in the video description if interested. I've already installed these before, so I'm just going to let it run, but that there may be new ones when you run it. Now, what I need to do is create a directory, and where I'll be cloning from Raspberry Pi's GitHub page And I'm going to go to that directory, and in here I will clone the libcamera repository by pasting this command, and it will clone the repo pretty quickly. It's not that big. Then what needs to happen is once the cloning is done, I go into the libcamera directory and I issue this Maison command to set up the build directory. And what I'm saying on this command is build type is release. The pipelines are for Raspberry Pi VC4 and Raspberry Pi PISP. And I am saying build it with v4l2, and I added this GStreamer equals enabled. Also, I have all the flags turned on. Test is true. This can be false if you, it's optional. LC compliance is enabled. That's also optional. CAM is enabled in my case because I want to have the CAM utility program. QCAM is also enabled, but I didn't enable building the documentation, but I did enable the PyCamera binding. So basically what this does, it will go through and set up the build, the CMake files, and it's just finding my compiler, GCC 12.2, and it's finding libcamera native build is the version being built is 0.3.2 for Arch64, and so on and so forth. Some of this is not that interesting, but if there's an issue, it's as helpful to be able to debug it, build issues. So I do want the GStreamer support. That's why the whole point of me building. The next thing is then at this point I could have, I guess, used Maison to build, but I will just say ninja -build. So this will just do the build like this, and it'll spew out a bunch of these characters. It'll 438 files to be built, so this will take a while. I'm going to pause and then come back. Okay, so the build is complete. It didn't take that long, and I now will install it using ninja build install. I mean ninja install. So it'll ask me for my sudo password, and that's it. You know, it's installed it already. What I want to do is I want to do some checks with GStreamer, okay? And in order to do that, I will use GST launch. So here is one just basic check. Okay, GST launch is working. Not that command. It's a different command here. I'm going to copy it. So in this command here, I'm saying to GStreamer to use the libcamera source pipeline, and I have to specify that it's a BGR format, and I want to have it at 640 by 480 at 30 frame rates, and I want to see it in the OpenGL image sync. And like you see, it says there is no libcamera source. So that's why I had to build it from sources, because now that I've built it, I can enable this path and say that, hey, I want to find the GStreamer pipeline in my build directory where I built it. So with that, if I were to actually take this command and paste it, I should be able to run that command that failed successfully now. So I'm just exporting that and then saying, there you go. And it's able to open it. So that was the issue, is without building it from source, I did not have access to this libcamera source pipeline. So I've opened up a new terminal because I have that GST variable, environment variable. I should have no problem running the GST commands here. And so here's another command that I needed to run. rpycam hello -- list cameras. Well, with 2 cameras possible in the Raspberry Pi, I needed to somehow be able to get the name of the camera that I wanted to open and pass it to the GStreamer pipeline. And the way to get the name of the camera is to use these rpycam hello -- list cameras, and the name that you want to pass to, that I wanted to pass to the GStreamer pipeline, is this long name. And so there are 2 camera module 2s, Raspberry Pi camera module 2s, which are based on the Sony IMX1219 sensor. They appear as these 2 long names. But really the only thing different between them is this number after the @ sign. The second camera is at 80, and then the first one is at 88. I have to give this whole thing. But if I want to open the first camera, I got to give that name. If I want to open the second camera, I got to give that name. See, bin cv timex, and when I run it, this is the pipeline that I can quit it here. But what you'll see is I'm using this GStreamer pipeline, and I'm giving the name, libcamera source, camera name, and that long name. That long name is the first camera. Okay, and I have 2 different settings files, so depending on where I run the program, it'll use a different camera based on the folder that I run it from. But because I have a different settings file in this folder. So here, in this directory, I will open the other camera. And what you see, here's the same pipeline, GStreamer pipeline. This is, by the way, I'm using OpenCV and telling OpenCV to use this pipeline to open the camera. So when I tried to use OpenCV itself to open the camera, it didn't work. So that's why I had to take this long route and use this whole pipeline. But this way I have a way of saying which camera I want to open. And so that's about it. That's it for this particular issue. By building the libcamera from source, I was able to add the plugin to the path, and then finding the camera names, these long camera names, I was able to use that to pass to the GStreamer pipeline. I think I'll save building the rpycam apps for another video. But for now, I think this is getting a bit longer than I wanted. So thanks for watching this video, and hope to see you in another video in the future. Bye-bye.